welcome to another deep dive. Get ready to have your mind warped a little bit, because today we're looking at Einstein rings.
Ooh, Einstein rings.
And more specifically, we're going to be looking at a brand new one discovered by the Euclid Space Telescope.
That's awesome.
Yeah, so this is a ring that has been found around a galaxy we thought we knew pretty well.
Oh, really?
It's called NGC 6505.
Okay.
And this thing has been observed by astronomers for over a century, but it took Euclid's incredibly sharp eyes to spot this phenomenon.
That's amazing. Yeah, Euclid has just opened up so many doors for us in terms of what we can see in the universe.
Yeah, so I'm really excited to dive into this with you because there's so many questions I have, like starting with what exactly is an Einstein ring?
Right.
And how does something like that even form?
Yeah, so Einstein ring, it sounds like something straight out of science fiction, right?
Yeah.
But it's actually a real phenomenon, and it all goes back to Einstein's theory of general relativity, which predicted that massive objects can actually warp the fabric of space-time. Imagine like a bowling ball on a trampoline.
Okay.
The bowling ball is going to create like a dip in the fabric.
Right.
And if you roll a marble across that trampoline, its path is going to curve around that dip. Right?
Yeah.
That's kind of what's happening with an Einstein ring.
Oh, I see. So the foreground galaxy is like the bowling ball, and then the background galaxy's light is like the marble, and space-time is the trampoline.
Exactly. You got it.
Whoa. Okay, so because that light is getting bent around the foreground galaxy, we see it as a ring.
That's right.
That's wild.
It is pretty wild.
So that's what an Einstein ring is.
Yeah.
But why is the discovery of an Einstein ring so significant? What does it actually tell us?
Well, it's more than just a cool visual. You know, it's not just a pretty picture.
Right.
It's really significant because it confirms Einstein's theory of general relativity.
Oh, okay.
You know, we're literally seeing gravity warping light from a distant galaxy, and that's a pretty big deal.
Yeah, that's incredible.
It's like the universe is putting on a light show for us just to prove Einstein, right?
Yeah, and not just any light show. I mean, we're talking about light that has traveled for billions of years to reach us.
Right. Billions of years.
It's hard to even wrap your mind around that kind of time scale.
It really is.
So, okay, you said it's more than just a pretty picture.
Yeah.
What else can we learn from these Einstein rings?
Well, they act like cosmic magnifying glasses.
Really?
Yeah. They allow astronomers to study objects that are normally hidden behind that closer galaxy.
Oh, that's cool.
So, you know, there might be a really faint galaxy or a distant quasar that we wouldn't be able to see directly.
Right.
But because the light from that object is bent and magnified by the foreground galaxy's gravity, it becomes visible to us.
So it's like we're getting a sneak peek at some of the universe's hidden treasures.
Exactly.
I read in the article that this particular Einstein ring around NGC 6505, it's telling us something kind of unexpected about this galaxy.
Oh, really?
Yeah, it seems like it has a relatively low amount of dark matter, only about 11%.
Oh, interesting. Yeah, that is pretty low.
Right. What does that tell us? Like, what's normal for a galaxy?
Well, most galaxies we observe have a much higher percentage of dark matter, often outweighing the visible matter by like a factor of 5 or more.
Oh, wow.
So NGC 6505 is kind of an oddball in that sense.
Yeah, is that unusual then?
It is pretty unusual, and it definitely raises some questions about what we thought we knew about dark matter and galaxy formation. You know, the standard model of cosmology suggests that dark matter should be a dominant component of all galaxies.
Right.
So finding a galaxy like NGC 6505 with such a low percentage it's puzzling to say the least.
I mean, is it possible that our models of dark matter distribution are wrong?
It's possible, yeah.
Or could there be something unique about NGC 6505 that we just haven't considered before?
Yeah, there are a few possibilities.
Okay.
Maybe NGC 6505 has interacted with other galaxies in a way that stripped away some of its dark matter.
Okay.
Or maybe there are processes at play in galaxy formation that we don't fully understand yet. You know, this discovery is really pushing us to reevaluate our assumptions.
It's almost as if this Einstein ring is sending us a message like, hey, you thought you had this all figured out, but there's more to the story.
Exactly. That's a great way to put it. Yeah, there's always more to learn.
And that's where the Euclid telescope really shines, right?
Absolutely.
It's not just about finding pretty pictures, it's about using those pictures to unravel some of the biggest mysteries in cosmology.
Yeah.
Like dark energy, for instance.
Oh, yeah. Dark energy. That's a big one.
So remind me again, what is dark energy?
So remember that cosmic tug of war we talked about before?
Vaguely.
You know, dark matter's gravity pulling galaxies together.
Right, right.
But then there's dark energy, which is this mysterious force that's pushing everything apart, causing the universe to expand at an accelerating rate.
Right, right.
So Euclid's mission is to create a 3D map of the universe,
Okay.
tracking this expansion over cosmic time.
So by mapping out how galaxies are distributed and how fast they're moving away from each other?
Yeah.
Euclid can help us figure out how strong dark energy really is.
Exactly.
And that's pretty crucial, right? Because it can determine the ultimate fate of the universe.
You got it. That's the big question.
Okay, so remind me again, what are the different scenarios for the end of the universe?
Well, depending on how strong dark energy is, the universe could expand forever,
Hmm,
becoming colder and darker over time.
right.
Or if dark energy weakens, gravity might eventually take over,
Okay.
leading to a big crunch, where the universe collapses back in on itself.
Whoa,
So we're talking about understanding the very end game of the cosmos.
that's heavy stuff.
It is, yeah.
It's incredible to think that a single telescope can unlock so many secrets about the universe.
I know, right? And all of this groundbreaking science is happening thanks to a phenomenon predicted by a theory developed over a century ago.
Einstein really was ahead of his time.
He certainly was.
And this discovery of the Einstein ring around NGC 6505 is just another testament to his genius. Yeah, it's a visual reminder that the universe is a place where the laws of physics can create truly mind-bending phenomena.
It's a humbling thought, for sure.
Yeah,
It really makes you realize how much we still don't know about the universe. We're just starting to scratch the surface.
that's right.
And speaking of scratching the surface, this is just the beginning of our deep dive.
Oh yeah,
We've laid the groundwork, but there's so much more to explore.
I can't wait. And we're back diving even deeper into this Einstein ring.
Okay, so we've talked about what Einstein rings are, how they form,
Yeah,
and we started to touch on some of the things we can learn from them.
right.
But I want to zoom out a little bit and talk about the bigger picture.
Okay, yeah.
Like, what does this discovery tell us about the universe as a whole?
Well, one of the biggest things this discovery highlights is the role of dark matter.
Okay.
Remember, Euclid's primary mission is to create this 3D map of the universe, right? Showing us how galaxies are distributed across vast distances.
Right, it's like creating a cosmic roadmap.
Exactly. And this map is going to be crucial for understanding dark matter.
Because...
Well, because we can't see dark matter directly,
Right.
but we can infer its presence by observing its gravitational effects on visible matter.
So it's kind of like an invisible scaffolding that's holding the universe together.
That's a great way to put it, yeah.
So Euclid is essentially mapping out this invisible scaffolding.
Yeah, it's showing us where dark matter is concentrated and how it's shaped the large-scale structure of the universe.
That's incredible. And you said earlier that dark matter and dark energy, they're kind of in this cosmic tug of war.
Yeah, exactly.
So how does Euclid help us understand that?
Well, by combining the dark matter map with measurements of how fast galaxies are moving away from each other,
Okay.
we can start to understand the influence of dark energy.
So if dark energy is strong enough, it could eventually overcome gravity.
Yeah.
And that could lead to a scenario where the universe expands forever.
Right, that's one possibility. It's called the big freeze.
The big freeze, that sounds a little ominous.
Yeah, it's not the most cheerful outcome.
What happens in the big freeze?
Well, basically, galaxies would just keep drifting further and further apart.
Okay.
Stars would eventually burn out, and the universe would become this vast, cold, and lifeless void.
So that's one possibility, but are there other scenarios?
Yeah, there are. If dark energy weakens over time, gravity might eventually take over.
Okay.
And that could lead to the opposite of the big freeze.
Well, the big crunch.
Exactly, the big crunch.
Okay, so in the big crunch, everything collapses back in on itself.
That's right. All the matter in the universe would eventually come crashing back together.
And what happens then?
Well, some theories suggest that it could lead to a new Big Bang.
Whoa, so like a cyclical universe.
That's one idea.
So it's kind of like a cosmic dance between expansion and contraction, creation and destruction.
It's a pretty epic dance, that's for sure.
But the big question is, which force will ultimately win out, gravity or dark energy?
Right, and that's what Euclid is helping us figure out.
It's mind-boggling to think that we're on the verge of unraveling such profound mysteries.
I know, and to think it all started with this simple observation of a ring of light warped around a distant galaxy.
And that's just one Einstein ring, right?
Yeah. Imagine what we'll learn as Euclid discovers more and more of these.
Speaking of this specific Einstein ring, the one around NGC 6505,
Yeah.
we talked about how it has this surprisingly low amount of dark matter.
Right?
Do you think that could be a fluke, or is that something that's really going to challenge our understanding of galaxy formation?
It's definitely a question that astronomers are grappling with right now.
Okay.
If it turns out that NGC 6505 genuinely has significantly less dark matter than other galaxies,
Yeah.
it would definitely challenge our current models.
So we might have to rewrite the textbooks.
It's possible, and that's what makes this discovery so exciting.
I love that. Science is a constant process of questioning and refinement.
Absolutely. There's always something new to learn.
It's humbling to think that even with all of our technological advancements, there's still so much we don't know about the universe.
It's vast and mysterious and full of surprises.
And that's what makes it so fascinating, right?
Totally.
I mean, we've talked about the scientific significance of this Einstein ring,
Yeah.
but I also just want to take a moment to appreciate its sheer beauty.
It is beautiful.
We're literally looking at the fabric of space-time being warped by gravity. It's like a work of art created by the universe itself.
It's pretty awe-inspiring.
It makes you feel both small and connected to something much greater than yourself.
Yeah, I get that feeling too.
It's like looking into a mirror that reflects not just our physical image,
Right.
but also our place in the grand scheme of things.
I couldn't have said it better myself.
So as we continue our deep dive,
Okay.
I just want to reiterate that this conversation has really highlighted the duality of scientific exploration.
Yeah.
On the one hand, we have this rigorous pursuit of knowledge, this quest to understand the fundamental laws that govern the universe. And on the other hand, there's this sense of awe and wonder, this appreciation for the sheer beauty and mystery of it all.
It's a beautiful balance.
It is, and I think that's what makes this particular discovery so special.
Yeah.
It's not just a data point on a graph.
Right.
It's a visual reminder of the profound beauty and mystery that lie at the heart of the cosmos.
And it reminds us that we're part of something much larger than ourselves.
Exactly.
Something we're only beginning to understand.
Well, I'm ready to dive even deeper into this cosmic rabbit hole.
Me too.
We've covered a lot of ground, from the science of Einstein rings to the mysteries of dark matter and dark energy.
Yeah, we have.
But I have a feeling there's still more to uncover.
There always is. The universe is full of surprises.
So when we come back, we'll wrap things up with some final thoughts and reflections on this remarkable discovery and what it means for our understanding of the universe. Okay, so we're back and ready to wrap up this deep dive into Einstein rings and all the cosmic mysteries they've uncovered.
Yeah, it's been a pretty wild ride.
Yeah, I think what struck me most throughout this conversation is the sense of wonder and humility that comes from exploring these topics.
I agree.
It's easy to get lost in the details, the equations, the technical jargon.
Yeah.
But ultimately, it's about something much bigger than ourselves, right?
Right. It's about recognizing our place in this vast and ancient universe.
A universe that operates according to laws we're only just beginning to comprehend.
And this Einstein ring,
Yeah.
this seemingly simple circle of light.
Yeah,
It's a powerful symbol of that, isn't it?
I think so.
This visual reminder that even in the most distant reaches of the cosmos, the laws of physics, the laws that govern our own existence, are still at play.
It's pretty amazing.
It
And the
is-
fact that we can observe and study these phenomena,
Yeah.
it's a testament to human ingenuity and our insatiable curiosity.
Absolutely.
I mean, we've come a long way since Einstein first proposed his theory of general relativity.
We have.
And now, with tools like the Euclid telescope, we're able to test those theories and refine our understanding of the universe in ways that Einstein himself probably couldn't have imagined.
And who knows what other incredible discoveries await us.
Right. This is just the beginning of Euclid's mission.
Yeah, we're just getting started.
And if this early discovery is any indication, we're in for a truly remarkable journey of exploration and discovery.
It's exciting to think about.
I think it's important to take a moment to just appreciate the sheer wonder of it all.
Definitely. The beauty and complexity of the universe we inhabit.
So, as we wrap up this deep dive, let me leave you with this final thought.
Okay.
If a simple ring of light can unlock so many mysteries, imagine what other wonders are out there waiting to be discovered.
Yeah. Who knows what's out there?
Keep your minds curious, your eyes on the stars.
Keep looking up.
And who knows, maybe one day you'll make a groundbreaking discovery of your own.
It could happen.
That's all for this deep dive. Thanks for listening.